can they apply into efundiwe ngotem fundeni term 1. All right. So let's see number 1. Number 1, you are given the first two terms of the geometric sequence. So your first term is t squared minus 6t minus 9. Then your second term is t to the exponent 3 plus 9t squared plus 27 t plus 27 all over 2. This is the first term, this is the second term, and we are told that this is a geometric series. Determine the values of t for which the sequence will converge. So that's the condition for convergence.
R must be greater than -1 but less than 1.
For convergence, we are saying R must be greater than
-1
but less than 1. But then we don't have R. So how do we find R?
T2 over T1.
So in a geometric we say T2 over T1. So what is T2? T to the exponent 3 plus
9t squared
plus 20
7t
plus 27 over 27 over divided by negative t squared minus
6t minus 9.
So we're having a fraction over a fraction. So how do we deal with this situation? We multiply with 7 times. Okay? So this will be the same as having t to the power of 3 plus 9t squared plus 27t plus 27 all over 2 divided by, again, divided by negative t squared minus 6t minus 9 all over 1, if we like. But then we have a problem. What is this? This is a cubic expression, again, cubic expression. So I suggest we go and factorize this separate, because we all know that we need factorization. Yes. So how do you factorize a cubic expression? So let's write it here. We have t to the power of 3 plus 9t plus 27t plus 27 t squared. So the first thing we need to do is to find a factor. How do you find a factor? You find the number of which if you substitute you get 0. So what will be that number? Negative 3, which means the factor will be t plus 3. Okay? Remember the B method or the synthesis. Let's apply the B method. So if we are applying the B method, that means this term here will be t squared, because we want, when we multiply, we need to get t cubed. And then you go and sort out your last term. So your last term will be 9. Because we want, if you multiply 3 by 9, you want a number. If you multiply by 2, 3, you get 27. So that will be 9. And then you say plus BT in this case, not BX. Okay? And then, from here, which combination are we taking? C squared. C squared. Okay? So we'll get C squared if we multiply these two. So we have BT squared 3t. 3t squared is equals to 9t squared. And then the t's will cancel out. Agree. The t's will cancel out. You are left with b plus 3 is equals to. So therefore, b is equals to 6. Now we know the value of b. So it means we have t plus 3. Instead of b, we are putting 6t now. So you have t squared plus 6t plus 9. Of which, again, this is perfect square trinomial. This is a perfect square trinomial. If you were to further simply factorize this, you'll have t plus 3 into t plus 3 again. You have t plus 3. So now we have factorized, or if you like, you can write it as t 2t plus 3 all raised to the power 3. Alright, so now we have factorized this. So instead of this, we are going to put t plus plus. Alright, so instead of this, we are putting t plus 3 all cubed. Oh, you are preferring all cubed, no problem. All over 2, it's fine. Then we say times 1 over, but again, it's 1 over, but then again, what can we do with the trinomial? We can take out negative, So this is negative into t squared plus 6t plus 9. Oh, they were correct when they said we have to leave it here, because we can see the cancellation. Alright, no problem, we can rewrite this step. So we will have t plus 3 into t squared plus 6t plus 9 all over 2. Then we say times negative 1. Can you see where I get negative 1? Yes. So this is t squared plus 6t plus 9. And then we have this cancellation. Then what is left now is that we have t plus 3 all over 2. But we know that this will be negative. So this is the value of r. Or you prefer to distribute this negative? No, we leave it here. So this is the value of r. Now, we go back to our rule for convergence, where we said r must be greater than minus 1 but less than 1. So instead of r, we are now putting negative into t plus 3 all over 2 is greater than minus 1 but less than 1. And then, how do we solve this inequality from page 10? We times by 2, which will have negative, let's distribute also here. So we have negative t minus 3 is greater than, what is this times 2? Negative 2 but less than 2. And then, take 3 to the other side, to the other sides in this case. Take 3 to the other, to left, then to right. Then you have negative t greater than 1. But less than 5. What do we do with that negative t? So we divide by negative 1. So if you divide by negative 1, what will happen to the inequality signs? They will change. So you will get negative 1, but then you will get negative 5. Then if you wanted to put your inequality sign to the original direction, in the original direction, you will have negative 5, then you'll have negative 1. So this will be your solution. 5 marks. So in? Alright, let's go and see number 2. Number 2, again you are given a geometric minus 2x over 3 plus 1 minus 4x plus 4x squared over 9 plus into 1 minus 2x all cubed over 27 plus. And then again, you are told that this is a geometric. Same question. They say determine the values of x for which the series will converge. So we'll follow the same procedure. So first, we need the value of r. So we are told this is geometric. So you said r is equals to t2 over t1. Or if you like, in this case, you can say t3 divided by t2. But then, or should we say that? Which one is easy to simplify? T2 over t1. Okay, let's go with t2 over t1. So we have r equals to t2 is 1 minus 4x plus 4x squared over 9. But then we can rewrite this as a division sign. So then we say divided by t1. T1 is 1 minus 2x over 3. Okay? And then what do we have in the numerator? This is a quadratic trinomial. This is a quadratic trinomial with factors that are 1 minus 2x into 1 minus 2x all over 9. Then we have a time, tip and times. Then this is 3 over 1 minus 2x. And then we have this cancellation. Then we also have this cancellation. Then the denominator will only have 3. Okay? So therefore, the value of r is equals to 1 minus 2x over 3. Right? And then from here, we go to, for convergent, r must be greater than negative 1 but less than 1. Okay? So what's the value of r? It's 1 minus 2x over 3 must be greater than negative 1 but less than 1. Again, we're having an equation like that. So if you solve this, cross multiply, multiply by 3 across. So you have negative 3, then you have 1 minus 2x, then you have negative 3, then you have 3. Then you take 1 to the other side, you only have minus 2x, then you have negative, greater than negative 4 but less than 2, if you take this one. Then you divide by negative 2. So if you divide by negative 2, the direction of the inequality signs will change again. Directions will change again. So you'll have negative 2, then you'll have positive 2, then you'll have negative 1. Then x is greater than negative 1 but less than 2. That was number 1. And then 1.3. In 1.3, you have to solve the equation which involve sigma notations again. Okay? So this is an equation you are required to solve. You have k equals to 1. Then you have 9x to the power of k. We are told that this is equals to. Then you have 14. Then you have t equals to 1. Then you have 24 minus 3t. We are solving for x. Okay? So we said, if you are confronted with such an equation, you treat this as its own entity, and also your right hand side. Then in the end you equate it. Okay, first let's deal with this. So what is happening here? We said the rule must be, first we find it, first 3 terms. So the first term will be 9x to the power 1 plus the second term 9x to the power 2. The third term is 9 to the power x to the power 3, and so on. As you can see, this goes to infinity. And then the value of a, this will be geometric. It's only a geometric series that goes to infinity. So now we want the value of a. The value of a is 9x. The value of r is x. How do you get x? You said x squared divided by 9x. Then you got x. Because this will cancel, then you only have 1. And then we go and compute the sum to infinity. So the formula for sum to infinity is equals to a over 1 minus r. So what's the value of a? 9x. 9x over 1 minus x is your r value. Okay. Then can we further simplify this? No. So we'll leave it like that. So we know this is our left hand side. Left. Okay. Now let's deal with the right hand side. So again, you apply the same procedure, the first 3 terms. So if you substitute 1, what are you getting? 21 plus. If you substitute 2, 18. Substitute 3, 15, and so on. Now we want the value of a. What's the value of a? 21. The value of t, since this is arithmetic, you say this minus, you get negative. Then the value of n, you say 14 top minus bottom plus 1. Even though it was unnecessary in this case, it starts with 1, but no problem. And then, are we ready to complete the sum now?
Yes.
Okay? If you like, you can use the formula that uses the last term, because you can find the last term through that 14 again.
Yes.
Okay, so let's go. So this is Sn equals to n over 2 into 2a plus into n minus 1 times d. And then you substitute. Instead of n, 14 over 2 into 2 into a, 21 plus into 14 minus 1 into negative 3. Then you go ahead and calculate that. What are you getting? 20? 21. So now this is the right hand side. This is the right hand side. So now we know the left hand side is equal to the right hand side. Okay? So we say 9x over 1 minus x is equal to 21. So now what we have to do is to solve for x. How do you solve for x? Cross multiply. So you will have 9 is equal to 21 into 9x is equal to 21 minus x. Very good. Then you have 9x is equal to 21 minus 21x. Then if you take this to the other side, you have 80x is equal to 20. And then x is equal to 7 over 10. If you simplify 21 over 8. Okay, very good. And then let's go to number 4. Number 4, what is happening number 4? What's happening in number 4? So let's see. Again, we have a sigma notation equation. They wanted the value of x now, right? So we have done. Again, they want the value of p. Number 4, we are given the sigma equation, then they want the value of k this time, 5 marks. So you have this is 10, this is k equals to p equals to k, and then you have 3 to the exponent p minus 1. You are told that this is equals to 29,520. You are required to find the value of k for 5 marks. Any suggestions? Find the first 3 terms. Okay. So the first term, for the first term you will substitute? Substitute k. So you have 3 to the exponent k minus 1 plus. What about the second term? 3 to the power k plus 1 minus 1. Why k plus 1? Because this number here increases by 1. Remember when we substituted k, because it started at 1. So the next number is 2. Okay? Yes. So if you have k, let's say k maybe represent 10. The next number will be 11. Again, 10 plus 1. Again. So that's how we got this k plus 1. What about the third term? It's 3 to the power of k plus 2 minus 1. Then we can simplify these terms. It's k minus 1 plus 3 to the exponent k plus 3 to the exponent k plus 1. These are the first 3 terms. And then we express the value of a, the value of r, the value of n, and it. And then we go and solve. So what's the value of a in terms of k? 3 to the exponent k minus 1. What's the value of r? How do we find r? So you say T2, which is 3 to the power of k again, divided by 3 to the exponent k minus 1. So I think we can simplify this. This will be, the bases are the same again. So we'll have 3 to the exponent k minus the denominators, minus plus 1. Agree? So the value of r will be, from this, will be 3. Okay? What about the value of n? What about the value of n? Top minus bottom plus 1, which means the value of n in terms of k will be 11 minus k. So now we are going to the sum for geometric, because we know that this is the sum. Then we equate the 29,520. So let's go to the sum. So it's Sn equals to a into r to the power of n minus 1 all over R minus 1. So instead of Sn, 29,520 is equals to, instead of A, 3 to the power of K minus 1 into, what about R? 3 to the exponent 11 minus K minus 1. All over R is 3 minus 1. Okay? So our first step, what do you propose? Times by 2, Can you see this 2, It times by 2. So if you do that, this will be 59,040. Then equals to, what about here? I propose we distribute, Yes. What if we distribute? Let's distribute. So now it's like we are saying 3 to the power of K minus 1 times 3 to the power of 11 minus K minus 3 to the power of K minus 1. Someone was suggesting that we add the exponents, but then let's include this step. Yes. Okay, then we still have 59,040 is equals to, so we add the exponents since the bases are the same again. Yes. So this will be 3 to the power of 3 to the power of 10, because K will cancel. So 3 to the power of 10, minus 3 to the power of K minus 1. Okay? Then this 10 to the other side, then this one, this side. Yes. Okay? So we have 3 to the power of K minus 1 equals to 3 to the power of 10 minus 59,040, which equates to, what is this? 9. It's only 9. Yes. We are through. Minus 1, then it's 3 to the power of K minus 1 equals to 3 to the power of 2. Then K minus 1 is equals to 2, which means K is equals to 3. Very good. Then you take your 5 marks. Okay. And then we go to number. Yes, question. Take a chat. All right, let's see number. All right, and now we are given, this is number 5, 3 over 4 plus 1 over 2 plus 1 over 3 plus, and so on. From this sequence or series of niggas, we are told that the sum to infinity minus Sn is exactly the same as 1,024 over 59,049. Then for 6 marks, you are required to solve this equation. The suggestions? Sum to infinity. Okay, for us to calculate the sum to infinity, we need the value of A, 3 over 4. Then we need the value of R, 2 over 3. Then the sum to infinity will be 3 over 4 over 1 minus 2 over 3, which is the same as 9 over 4. So instead of sum to infinity, we know that we have 9 over 4. Minus, what about Sn? Sn. We substitute in the formula for the sum in geometry. But then n will be the only variable. Okay. So instead of A, we put 3 over 4. Into, instead of R, 2 over 3. All raised to the power of n minus 1. All over 2 over 3 minus 1 is equals to 1,024 all over 59,049. And then from here, all right. Can you evaluate this in your calculators? Just evaluate this term. What are you getting? 9 over 4. All right. So this is 9 over 4, or positive 9 over 4. Is it positive? Or negative into negative 9 over 4 into 2 over 3 all raised to the power of n minus 1, okay, is equals to 1024 over 59,049. Okay. People are saying if you say 3 over 4 divided by this number, you are getting negative 9 over 4. That's right. Alright. So, and then from here, distribute by, we transpose which term? 9 over 4 to the other side. Okay? 9 over 4 to the other side, are you sure? Okay? Okay, let's do it quick, I think. So this is 9 over 4 minus into, let's distribute this 9 over 4. Here. We will have, we will have negative 9 over 4 into 2 over 3 all raised to the power of n. Then we have plus 9 over 4. Then you close bracket. This is 1024, 59,049. And then distribute the negative. Okay, let's do that. It's 9 over 4 plus 9 over 4 into 2 over 3 all raised to the power of n. And then minus 9 over 4 is equals to 1,024 all over 59,049. And then what happens now? This will cancel, This will cancel out. Now we are left with 9 over 4 into 2 over 3 all raised to the power of n is equals to 1,024 over 59,049. And then we have 2 over 3 all raised to the power of n is equals to. Alright, don't put the zeros. What if, can you write this as a prime number, this number? 1024 as a prime number. It's 2 exponent? 2 exponent, oh, what about 59,000? 3 to the exponent 10. Oh, so this number can be rewritten as 2 over 3 all raised to the power of 10. Okay? Remember, we still need to divide by, again. We are dividing by 9 over 4, So divide by 9. Is it okay if I say times 4 over 9? Yes. Times 4 over 9. Okay? So this is 2 over 3 all raised to the power of n is equals to 2 to the power of 10 times 2 to the power of 2, all over 3 to the power of 10 times 3 to the power of 2. Then this is 2 over 3 all raised to the power of n is equals to 2 to the power of 2 to the power of 12 over 3 to the power of 12. Is it okay if I write it as all raised to the power of 12? Yes. Then n is equals to 12. Alright, okay, let's continue. Now we are in 1.6, Okay, so there are so many ways in which you can solve this. So Nakona, we should get 12 as the answer. Alright, so now 1.6. It's a word problem. In an arithmetic sequence, the 10th term is 28. The 10th term is 28. See, 10 is equal to 28. The sum of term 5 and term 7 is equal to 32. Calculate the sum of the first 50 terms. Let's consider the sum of term number 5 and term number 7 is equal to 32. So this is T5 plus T7 is equal to 32. This is arithmetic. So if it's arithmetic, how do we express T10? Okay, let's go and apply and use the formula. We are using the formula to express this again. So if you substitute 10, you will have A plus into 10 minus 1, then D. D again. So T10 is A plus 9D, which is equals to 28. Okay. And then T5 A plus. Oh, we are making A the substitute formula here. Okay, so therefore A is equals to 28 minus 9D. Oh, very good. And then T5, we can express T5, eh? So T5 is 4, A plus 4, D. What about T7? A plus 6, D is equals to 32. Then if you simplify, you have 2A plus 10D is equals to 30. We can simplify this equation further by dividing by 2. Eh? So this is A equals to 5. Okay, A plus 5D is equals to 16. Then we make A the substitute formula again. So A is equals to 16 minus 5D again. Okay. And then A is equals to A. Okay, so A is equals to A. Instead of A, we put 28 minus 9D. This is equals to this A, which is 16 minus 5D. And then we solve. So if we take this to the other side, we'll have negative 4D equals to negative. Then D is equals to 3. They want the value, or they want the sum. So let's go and find the value of A as well. So the value of A, we have to substitute. It's 28 minus 9 into 3. And then you get 1. Okay. So now they want us to calculate the sum of the first 50 terms. So let's go and use the formula for arithmetic. So this is 2A plus into n minus 1D. Instead of n, we know that we are going to put 50. 50 over 2 into 2 instead of A, 1 plus into 250 minus 1 instead of D, 3. Then close bracket. Then this is 3,725. Then you get your full marks for number 6. Eh? Alright. Then let's go to number 7. Let's go and approach number 7. Let's go and approach number 7. Okay, number 7. In a geometric sequence, the sum of the first of T3, 4, and 5 equals 28. Okay, how can we interpret that information? T3 plus T plus T5 is equals to 28. And then the statement continues and says the sum of 10, 6, 7, and 8 is equals to 224. Which means that's another equation, eh? Which says T6 plus T7 plus T8 is equals to 224. I think this is easy. Okay, this is geometric, eh? So in a geometric, if you express T3 using Tn, it will be A R to the power 3 minus 1, which is 2, plus A R to the power 3, because it's 4 minus 1, plus A R to the power 4 is equals to 28. Okay? Then what do we do with our first equation? Is there anything we can do? Common fact. So what's the common fact? AR squared into 1 plus R, plus R to the power 2 is equals to 28. And then AR, we divide. So we make AR the substitute formula. So it's AR squared is equals to 28 over 1 plus R to the power 2. Is this our first equation? Okay. And then we go and find the second equation. What is T6 in terms of the general rule for Tn? A r to the power of 5 plus a r to the power of 6 plus a r to the power of 7 is equals to 224. Yeah? And then, again, we take out common factor. Okay, common factor a r to the power of 5 into 1 plus r plus r squared. Okay, is equals to 224. We do the same thing. Eh? But if you like, we could have made this the subject of the formula. It would have solved as well. Eh? But no problem. A question? A r squared, the subject. Oh, we split this. Okay. Eh?
A r squared into r squared plus r 2.4 plus r 2.5.
So you say you have r times a r squared.
Yes.
Again.
Yes.
A.
No, say A r squared.
You're saying A, then you're splitting r to the power of 5.
A r squared.
A r squared. Yeah?
Into
Into
r
r to the power of 3. Oh, okay. We should show this step. This is distributing, is splitting this r to the power of 5 again. Yes. Because she wants to make this the subject of the formula so that she is able to equate again. Yes. Okay, let's do that. So this r cubed is being distributed in this trinomial. Yes. So this is r cubed plus r to the power of 4 plus r to the power of 5 is equal to 200. Okay? There are so many ways in which you can solve this. Now lay right. So you're making ar squared the subject of the formula. Eh? So it's 224 all over r cubed plus r to the power of 4 plus r to the power of 5. And then you're saying ar squared equals to ar squared. Yes. Okay. So ar squared is equal to ar squared, which means 28 over 1 plus r squared is equals to 224 over r cubed. Okay, r cubed plus r to the power of 4 plus r to the power of 5. And then from here, cross multiply. So you cross multiply. This will be multiplied to 28. So it's 28. And then in the same process, we take out common factor of r cubed. So it's r cubed into 1 plus r squared is equals to 224 into 1 plus r squared. Then we can see that 1 plus r squared will cancel out. All right, let's continue. Then this trinomial is cancelled out now. Then we are left with 28 r to the power of 3 is equals to 224. And then this is r cubed equals to 8. Then r is equals to 2. What was the question? What was the question? Did somebody did? First 3 terms, which means we need the value of a. So where are we getting the value of a? In this equation. Instead of r, we are putting, so now we are substituting this r equals to 2 in that first equation. So a into 2 all squared is equals to 28 over 1 plus 2 all squared. Then you divide by 4. So a is equals to, you compute this, then you divide by 4. Then r is equals to 1. So therefore, the first 3 terms, term 1 is going to be 1. The second term, 2, because r is 2. 2 plus 4 and so on. Since they are looking for the first 3 terms. Okay, very good, very good. Very good, Sisi. Alright. But then, is there anyone who did it different? You all right, you're just discussing your solution. Because you had this option to make this the subject of the formula, this trinomial. Then you equate the two. Okay. Alright, and then number 1.8. 1.8. All the terms of a geometric series are positive. The sum of the first two is 34. From that statement, what are we taking away? The sum of the first two is 34. T1 plus T2 is equals to 34. 34. Okay. And then after that, they say the sum to infinity. The sum to infinity is equals to 162. Okay. Then the question says determine the common ratio, which is the value of R, right? Okay. And then from here, because I suggest we write this. Again, this is geometric, yeah? So we say A, just A. The first term for geometric is A, yeah? Yes. And then the second term will be AR is equals to 34. Take out A as common fact. Yes. Okay, so we have A into 1 plus R is equals to 30. And then divide. Okay, so we make A the subject of the formula. So it's 34 over 1 plus R. This is our equation 1. And then, how do we deal with the second equation? 162 is equals to A over 1 minus R, the sum to infinity. Yeah? And then, we substitute. Instead of this A, we are putting that. Alright, so we have 162 is equals to, instead of A, 34 over 1 plus R divided by 1 minus R over 1. Okay? And then, different times. So it's 162 equals to 34 over 1 plus R times 1 over 1 minus R. And then 162 is equals to 34 over the different two squares. Eh? Different two squares, this is 1 minus R squared. And then cross multiply. So that will give us 162 minus 162 R squared is equals to 34. Quadratic. Eh? Quadratic? No, it's not quadratic. We take this and then what are we left with in the R left hand side? If you take this 34 to the other side, you'll have 162 R squared equals to 128. And then we divide by 162 both sides, which means R squared is equals to 64 over 81. Then you square both sides. So therefore R is equals to plus or minus 8 over 9. But we had a restriction. Our restriction said all numbers are positive, which means R is equals to 8 over 9. And then you take your full marks. Okay. Question, yeah. Alright. Alright. Yeah. Question, okay. Yeah. 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 Yeah, when to A is substitute formula. What's A equals to A? Yeah, correct. Correct. Yes. Correct. Figure out the final, eh? Alright. And then, very good. And then we are given the first question. Oh, yeah. 0.88 and negative 1, comma. Where did you get it? Here. At at this stage?
It sum to infinity. Instead of a, we substitute 34 minus a squared.
Sum to infinity. Instead of this a, you put
34 minus a squared.
where did you get the 8 minus?
24. Yeah, so the equation 1 mark, you will do a r.
Oh, so all right, very good. All right, and then we are doing number 1.9 now, 1.9. 1.9, we have minus 2 is to 6 is to 22, and so on. These are the first 3 terms of a sequence, okay? Let's try. If the same number is added to each term of these terms, the result is a geometric sequence. Determine the number. Okay, so what are you suggesting here? Let the number be? Let the number be x or equals to x. Okay, which means in the first term will be negative 2 plus x or x minus 2. Okay, then the second term will be so x plus 6. Then the third term will be x plus 22 because we are adding x when our common terms again. But then they are saying this will become geometric. Okay. Then the question is determine the value of x. Okay, so how do we find the value of x in this case? R. We're using R. The fact that T2 over T1 is equals to T3 over T2. Okay, instead of T2, x plus 6 over x minus 2 equals to x plus 22 over x plus 6. And then you solve this equation. How do you solve this equation? Cross multiply. So if you cross multiply, you'll have x squared plus 12x plus 36 equals to x squared plus 20x. 20x minus 44. Then x squared cancels x squared. Then you have negative 8x equals to negative 8. Then x is equals to 10. This one was easy. Maybe it was easy. I'm not sure. Was it easy? Yes. 1.11. The sum of the n terms of the arithmetic is given by Sn equals to which term in the sequence will have the value of negative 169. When you are given the sum, which rule are we applying when given the sum now? Remember that rule? We are doing number? Oh, we are doing number 10. Sorry, so number 10 we are given the sum Sn equals to 2n to the power of 3 minus 2 minus 3n squared plus 5. And then they want you to calculate T8. You are given the sum, they want you to calculate T8. So we refer to each rule. The one that says Tn is equals to Sn minus 1. So which means this is T, they are looking for T8. T8 is equals to S8 minus S7. Then you go and calculate S8 separate, or we substitute in this equation. Substitute. So let's go and substitute 8. So this will be 2 into 8 all raised to the power of 3 minus 3 into 8 all squared plus 5. This is S8 again. Minus S7. So S7 will be 2 into 7 all raised to the power of 3 minus 3 into 7 squared plus 5. But then for a marker, you need to give them this number. What will be that number? 100 then? 837 minus back or 544. So that means T8 is equal to 290. Ungafiki aya number 12 asiva le. That's because it's over 3 is because it's not for the